Hello, Assalamu alaikum. Welcome to the Electrical Measurement Lab. Today we will see the hardware experiments in Electrical Measurement Lab. If we go for the first experiment, calibration of power supply. So, see, first of all, what is meant by calibration? Calibration means comparison. We will compare the voltage which we are getting for the supply voltage with the standard supply voltage so that we can check whether the coming supply is according to the rated value or not. So please read this manual carefully. So the questions in the exam will come from this manual. Okay, so this is acronym PARD, periodic and random deviation. Like this, there may be questions in the exam. So coming to the THD, total harmonic distortion. So like this, there may be some questions. So what are the components we require in this experiment? We need a mobile workstation, AC voltmeter. Sorry, this is printed as AC voltmeter. Please change this as DC voltmeter.
Hello, Assalamu alaikum. My dear students, today we will see electrical measurement lab hardware part. If we see the experiment 1, this is calibration of power supply. Here we will see what is how much power is coming, how what is the value, it is underrated or not, it is exceeding the rated value or it is below the rated value. We will compare the power supply with the standard supply. So this is called calibration. So calibration means comparison. So please read the manual carefully. These acronyms may be asked in the examination. PARD, THD, all these things. So the equipment required for this experiment is mobile workstation, AC voltmeter, and DC voltmeter, power supply, and connection leads. So see, we will connect the circuit like this. Mm, so if I this. So what we will do, we will connect 3 voltmeters between 3 power supply terminals, 4 and 5 1 voltmeter, 5 and 6 1 voltmeter, 4 and 6 1 voltmeter. Okay, and already on the panel we have a voltmeter, so we will take these two readings here and the panel voltmeter. So if you see the procedure, we will connect the circuit, we will turn on the power supply, and we will adjust the line to neutral voltage to exactly 120 volts. We will measure and record each line to line voltage in table 1. So what is table 1 here? See, we have connected the voltmeter between these terminals, and we have set the voltage to 120 volts on the panel voltmeter, and we will measure the voltage here. So suppose if we have, uh, let's suppose we have here 125, then what will be the error? We have a error of 5 volts. Suppose here it is measuring 115, 115. So then we have here minus 5. And here, suppose if we have uh, exactly, sorry, it can, if we have 120, the error is 0. So what will be the average here? 120. And here, what will be the average? You can calculate 120, 115 plus 125. If you sum these three, how much it will be? We have to add 120 and 115 and 125. So total it will be 360. If we divide it with 3, so it will be again 120. So here what is the error? It is 0. Suppose if it is not like this, suppose here if we have uh, 125, 125, 125, so we will take the average here, and here error also we will take the average. Okay, so next what we will do, we will connect the circuit between 4 and n, 5 and n, and 6 and n. Same like this, here we will measure the voltage, how much it is. So whatever the voltage we measure here, we will get it, and we will calculate the error. 5, 10, this is, so you can calculate the average. Suppose then what we will do, we will change the terminals to 1 and 2, 2 and 3, and 1 and 3. Means we will connect a voltmeter between 1 and 2, another voltmeter between 2 and 3, and another voltmeter between 1 and 3. So same like this, we will measure the voltage here. So calculate the error here and take the average. Same, the procedure will continue here. We will connect between 1n, 2n, and 3n. So what we will do here, we will take the readings what we will get at that time. So here now for virtual lab, you can take a random value here and you can take the error. You can calculate the error. Then we will connect one voltmeter between 7 and n. We will take the voltmeter 8 and n, and we will take the 1 voltmeter. So this is our first experiment. Okay. Now coming to the experiment 2, here we will calibrate the ammeter and voltmeter. So what is the equipment required? This is the equipment required: mobile workstation, resistive load, AC voltmeter, AC ammeter, power supply, multimeter, and connection. So what we will do, we will connect a circuit like this, and we will measure the uh, current from the standard ammeter and the ammeter under test. Suppose if we have a standard ammeter reading is 10, and here if we have 9, so what will be the error here? It will be minus 1. Okay, so correction, how much we have to add here? We have to add 1, so that the error will be 0. So percentage error, how we will calculate the percentage error? So this standard ammeter reading, and this sorry, under ammeter under test, and minus the standard ammeter reading, and it should be divided with standard ammeter reading, and you have to multiply with 100. You will get the percentage error. So you can take some random values from, what we will do, we will take 10, 20, 30 here, 40. We will increase up to 120, 50. This is 60. This is 70. This is 80. This is 90, and this is 100. And here you can take the randomly, maybe here the error may be 2, so here it may be 32, like this. You can take some random values and you can calculate the error. Okay, so this is the percentage error formula. Then we will go for the calibration of voltmeter. So here we will connect the voltmeters in parallel, and we will take the readings. So like this. So here you can take the random error value and you can calculate the error. Here it may be 98, like this. Okay. And you can calculate the table, you can fill the table, and you can calculate the percentage error. Okay, so that will be our experiment 2. Now coming to the experiment 3, what we will do, we will measure the resistance, inductance and capacitance. So what is the equipment we require here? So this is the equipment we need: mobile workstation, resistive load, inductive load, capacitive load, AC ammeter, AC voltmeter, single phase wattmeter, power supply and connection leads. So first of all, we will take a resistive load and we will connect the circuit. So how we are connecting? We are taking from 4 to wattmeter connection 1, from 3 to ammeter, and from ammeter to load, from load to 4, 4 to 2. It is already connected internally, so 2 to n. Then we will apply a voltage and we will measure the voltage and current and wattmeter reading. So in the second circuit, we will change the resistive load with the inductive load, and then in the third one we will change the inductive load with the capacitive load. So observe one thing here: all the meters which we are connecting here, they will measure the RMS value, and the wattmeter will measure the active power. Okay, so whatever may be the load, the wattmeter will measure the active load. So in the first one, we will take the, what is the voltage, what is the current, and what is the power. So from this second circuit, we will same voltage, current, and power, voltage, current, and power. But what we have to note down here, uh, this will be our active power always. Here it is our active power. This is also our active power, and this is also our active power. So what is meant by active power? Active power, W will be equal to VI cos phi, or you can say theta, cos theta. So what is the theta here? Theta is the angle between this voltage and current. So this angle between voltage and current will be 0 if it is resistive load. If it is resistive load, this theta will be equal to, here the theta will be equal to 0. Uh, and in the pure inductor, if it is pure inductor, the theta will be equal to 90 minus in the inductive, and in the capacitive, this theta will be uh, positive 90, means leading. So this is called lagging. Here it is called lagging, and this is called leading. But here the capacitance and inductance which we have used, it is not a pure, so the angle may not be exactly 90, that we have to calculate. Okay, so now how to calculate this resistance apparent power. What is apparent power formula? Apparent power will be calculated as V multiplied by I. Okay. And reactive power, how we will calculate? V multiplied by I multiplied by uh, sin phi, sin theta, sin theta. So how to calculate theta here? Phase angle of the resistive circuit. Theta we can calculate as R by Z. R divided by Z. So here in this case, R and Z are same. So it will be equal to 1. Okay. Uh, Otherwise, how we can calculate this theta? Another formula to calculate theta is active power theta will be equal to active power W divided by VI. Like this also we can calculate. Okay. So mm, sorry, VI W is VI cos phi. So we will get cos phi here, not theta. This will be cosine. You have to calculate cosine inverse. Cosine inverse of this. It's cosine inverse. Okay. So resistance value, how we can calculate? We can calculate resistance value as V by I. Directly you will get the resistance value. Now coming to the inductive apparent power. Inductive apparent power, how we will get? If we multiply V and I, we will get the inductive apparent power. And the inductive reactive power, how we will get inductive reactive power? This V should be multiplied by I and it should be multiplied by sine theta. Phase angle, how we will get the phase angle? Phase angle we will get as same formula. uh, Cosine inverse of cosine 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 inverse of this W by Vi. Inductive reactance, how we will get the inductive reactance? X will be equal to same V divided by I. And reactance value, L how we can calculate in this value, reactance value, how we can calculate? Sorry, here it is written reactance, just change it as inductance. This is inductance. Inductance. So how we can calculate inductance? Actually, for reactance, the formula is X is 2 pi F and multiplied by L. So what will be L become here? L will be X divided by 2 pi F. So F here take pi value equal to 3.14 and F value is equal to 60. So you can calculate the inductance. So for the capacitance also same procedure you can follow. Okay. So and you can analyze the results. Why the angle? What is the angle? Why the angle is lagging in the inductance? Why the angle is leading in the capacitance? All these things you can analyze here. Okay. So these are the three experiments we have to see in the hardware part. Okay, so if you have any doubts you can contact me through email or you can contact me in the course message. Thank you.